In this lesson, we're going to talk about solving quadratic equations. So our goal is to get x squared by itself. We are going to have two solutions. So when solving an x squared equation, we will have two solutions. So when you do the square root of something to undo that x squared, when you do that, you have two answers and you need that plus minus. So here x squared's already by itself. So we square root to get rid of that x squared, the squared, and just have x. And then we have a plus minus, meaning you have a positive and you have a negative, and the square root of 36 is 6. So when solving the equation, we have plus minus when taking the square root. Okay, and we're going to write it in reduced radical form. So we're going to kind of simplify that radical and we'll review that. So here we're going to divide by 2 because we need to get that x squared alone first before we do our square root. And then now that it's alone, we can do our square root. And when we square root, again, we have a plus minus and we have just our x. And then the 12, we want to think about what times what gives me 12. And so we want to simplify. So 4 times 3, and then I look to see any of those that are a perfect square. Remember, our perfect squares are 4, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and so on and so on. So all of those we want to look for kind of a factor, or just break it down as much as you can and kind of pull out the 4s and the 9s. So when 4 comes outside of the radical, the square root of 4, it becomes a 2. Okay, and then the 3 isn't a perfect square. It has to stay under that radical. So there is our final answer. All right, so on this one, we're going to add 10. And so x squared is equal to 44. And then we'll do our square root. And so x is equal to plus or minus. And then I think about, well, 44 is 4 times 11. And I can take out the 4, and I leave the 11 under. All right, go ahead and try 3 and 4 if you'd like. And then push play and check when you're ready. But take a chance to try them on your own, and then push play and check. X squared is equal to 24, and we square root, and x is equal to plus or minus the square root, and 4 times 6 gives me 24. So the 4 comes out, the 6 stays home, and there is my answers. Positive 2 radical 6 and negative 2 radical 6. And then on this one, 4, you're going to divide by 5. So x squared is equal to 81 over 5. And then I'm going to square root. And so x is equal to plus or minus. And then I'm going to look to see, well, 81 is a perfect square. So I can do, it's kind of like splitting it up, giving the square root to each. And I can actually do the square root of 81. And that is 9. But now I can't do the square root of 5. And I don't want a radical on the bottom. So I'm going to take and multiply, which is what's called rationalizing that denominator. And when I multiply on the bottom, I have to multiply the same thing on the top. So top and bottom, because that's like 1. It's not really changing it, but changing the look, but not changing the value. So we just put these next to each other, 9 radical 5. And we multiply these, and that gives me the square root of 25, which is 5. No longer now a radical on the bottom. And then don't forget your plus minus with in front of that. All right, so we're going to do our day 2 within our day 1. This day 2, what we're doing is kind of 2 steps now to get x squared alone. So add 7, and then we'll divide by 4. And again, these are perfect squares, so I'm going to go ahead and leave it, not actually divide. I'm going to leave it, do the square root, and then I'm going to have the square root, so plus or minus the square root of 25 over the square root of 4, which are both perfect squares, so I can go ahead and have plus or minus 5 halves. Right, on this next one, I'm going to subtract 2. So 1/3 x squared is equal to 7. And then I'm going to multiply by the reciprocal to get rid of that 1/3. And then I'm going to do the square root. So x is equal to plus or minus. And then 21, it just has 7 and 3, and neither of those are perfect squares, so I leave it under the radical if I can't simplify it. All right, so try 3, and then push play and check when you're ready. This one we have to rationalize. So square root of 2 over square root of 5. When it's all under 1, we can separate. And so we're rationalizing the denominator because we don't want a radical in that denominator spot. So square root of 10 over 5, or square root of 25, and then you can bring that to a 5. And we cannot simplify a radical over a non-radical. So this stays radical 10 over 5. We cannot simplify a radical and a non-radical. All right, so over here, don't forget your plus minus, add 5. And then we're going to square root because this whole thing is squared. So we're going to square root. So plus or minus 4, x plus 2 equals plus or minus 4, and we're going to go ahead and solve. So subtract 2, and so I'm going to have negative 2 plus 4 and negative 2 minus 4. So my two answers are going to be 2 and negative 6. So I can actually add and subtract those. So try number 5 and then push play and check when you're ready. And you should have gotten negative 4 and negative 10 because we're going to take and subtract our 7, so it's negative 7 plus 3, and then it's negative 7 minus 3.